Well, good morning, everybody. Thanks for spending part of your weekend talking about the dirty, ugly world of data cleaning. We're all in this together. I think that if you've been following the recent news story about janitors in the public schools here in Chicago, I think it's a good analogy. It's something that if you don't take it seriously, it gets ugly quickly. I don't pretend to say that I have the answers to all your data cleaning problems, but this is something that I've had to wrestle with myself recently. So hopefully this can be a space where we can share our common problems, identify some tools and practices that will benefit us together, and maybe we'll even get a chance to throw some data into some of these tools and look at it together and end up with something cleaner. Most of my recent work cleaning data has been around a project trying to analyze and visualize records of criminal convictions in Cook County, and also my work with open elections, which is a project that's trying to standardize and clean up state elections data and make it available to researchers and journalists. So a lot of the examples of dirty data that I'm going to be talking about come from those two scenarios. So in the convictions data, when we talk about dirty data, this is some of the stuff that I'm seeing. This is just a small subset of dozens and dozens of different spellings and spacings of the city where we are now. This is a little bit harder to parse, but we got the data in CSV, and here you can see this is a statute. This is like describing a crime that someone was convicted for involving guns, and the quotation mark is designating inches, the size of the weapon. But the way that was escaped, either by the database program or somebody who did processing on the data before we received it at our project, is causing what should be two fields, one describing the conviction, the charge, and one describing the class, that final F, which stands for felony. Those are compressed into a single field, which means in that particular row in data, all the fields that follow this one will be off by one. And so that's something we'd have to fix to do our analysis correctly. Another problem in this project, and one that I see a lot, is when people try to combine two values into a single column in tabular data. In this case, there's different penalties in Illinois for attempted crimes and actual crimes. And there is a statute, 720-5/8-4, that is for all attempted crimes. And so what you see here and throughout our data set is where you combine the actual crime, the part in parentheses, and the attempted bits into a single field. And the way that's done is sort of arbitrary. So that was a big problem that we had to clean in order to identify what kind of crime we're talking about. And also the coding systems in a data set that spans a number of years can be really different, or depending on how it's generated. In this case, the statutes were referenced by both the older Illinois revised statute codes, which are the first three values, and the newer Illinois compiled statute codes. So even though we're talking about the same crime of murder, there's two different codes in that statute column. And that's another thing that we have to clean up and kind of normalize. And sort of the final ugly data example that I've been dealing with is an encoded value. So this is a column that represents the minimum sentence that someone could receive for their conviction. It's a number. You'd think that you could just compare one to the other as a number. In actuality, it's an encoded value. So it's an 8-digit number where the leftmost digits represent the number of years, the middle ones represent the number of months, and the final ones represent the number of days that the person could be sentenced to. And there's special values for like all 8s or all 9s for either a life sentence or a death sentence. So we'll talk about why it's important to like understand the data that you're getting before you start cleaning. This is a good example of that, of the motivation for it. So the Wi-Fi here is a little sketchy. This was a picture of somebody holding up a flashlight. It's scary story time. Really quickly, if any of you have some recent examples of scary really dirty data that you've had to wrangle with in your own lives, this would be an awesome time to share it quickly. Yeah.
Generally, I find character encodings are really hard to deal with.
Yeah, definitely. Like Latin 1 character encodings and otherwise reasonable data breaks all kinds of things. Absolutely. Anybody else that have some data scary stories?
So we got the red X addresses from the city of Chicago in a 44-page PDF that we can scan in OCR, and the OCR process left a lot of the addresses very, very dirty and disgusting.
Yeah, address data is commonly super dirty.
So the state of New Jersey maintains 2 different IDs for all of the students in the system, and they put a field on one of their data sets, which was ID, and it didn't specify which one was used. Turns out it was both, and then there was a collision.
So both, like, some records had...
They said, here's a unique ID, but it's actually 2 different types of unique IDs, some of which are type A, some of which are type B, somewhat randomly distributed. Yeah, and then there was a collision, and then I cried a little bit.
Yeah, it sucks. And that's sort of similar to the 2 different kinds of legal citations. Anybody else really quickly have a data horror story that they want to tell?
I think just from the university perspective, it's like the people entering the data aren't trained the right way. So whenever you have like a text field where you can just type in whatever, like if you're not trained, you know, they type in wrong, and then it's hard to compare.
Yeah.
Yeah.
That's
data entry mistakes or.
And I think oftentimes people doing research or in the nonprofit world especially, like the sort of data acquisition feels like an afterthought of their work. You know, people aren't stoked on doing that evaluation, and certainly not on typing paper forms into a digital system. So that definitely trickles down to people
Also
doing the analysis.
bad forms, I feel like.
Mhm.
So a lot of times it's like, you know, a city form should not be an open text field.
Yeah.
If you know you're doing a survey in, you know, Chicagoland.
Yeah.
It should be like a checkbox, selects or some, so like bad forms leading to like bad input.
Definitely.
'Cause people
So
aren't perfect.
these are all things that I've certainly run into. It's good that we're at least facing this pain together. So that brings up a good point. How many of you are cleaning data that your own organization has created? So you're both the source of the problem and so some of you. That's sort of a unique position, especially as you're starting new projects. So instead of just throwing up a Google form, sort of really thinking about what the end game is. What do you want to know about the data? Are you just counting the number of responses? Are you trying to cluster based on demographics? You know, what do you want to find from this data, and let that guide how you design your form, how you design your data acquisition. As you're doing this, you should make a data dictionary. So before you even start acquiring data, document what fields you want to be collecting, what the values are that should be in there, whether there's any validation. Even if you don't implement that technically, at least document it somewhere so you can know when your data has become dirty because it doesn't line up. And that's something that you can share with other people in the organization who are doing, you know, transcribing the paper documents. And then if you have the opportunity, test that acquisition process. Have people type in a couple of paper forms, have people enter data into the spreadsheet, and see if there's some obvious friction points where people are trying to cram multiple data into a field, or if you have a lot of misspellings in the 30 or 100 rows that you're looking at. And that can help you address that as opposed to having to do it on the tail end. And then if you're able to ask some of those questions through in your spreadsheet application or in your database application to do some of those queries or to do some really low fidelity charts in Excel, you can make sure that you're collecting the data that you need and on that small subset, whether it's lining up. I think it just saves so many hassles. My background is as a software developer, and so I prefer tools that are on the command line or that are based on programming languages. I know that's certainly not in everybody's wheelhouse and not something that everybody wants to acquire, but there are some really important things about those tools that should be part of everybody's data cleaning workflow, and that's that the steps that you're using to clean your data are very explicit, that you can easily document the transformation of your data, and that you can replay that. So starting from the dirty data, you can replicate the process that you're doing in cleaning and end up with the clean data. One sort of more graphical tool that does a good job of meeting those criteria is OpenRefine. I don't use it as frequently as the programmatic tools, but it's really great. And for many of your data processing needs, I would say that would be where I'd look first. You can do some lightweight stuff in spreadsheets directly. I've had a lot of problems with that, specifically around performance. Opening medium-sized data sets and doing a lot of edits can be pretty slow and frustrating in what's already a slow and frustrating process. So a big part of making data cleaning work better is before you just start noticing things that are messed up and changing them, trying to transform them, is getting a sense of how big the scope of your cleaning problem is, deciding what to clean, just general planning. So getting a data dictionary for the data set, whether it's one that was created in your organization or from the government agency that's giving you the data, is super, super important. There's a lot of things you can assume, like that sentencing field that I showed you earlier, that it's just a numeric value. I would have never thought that it was encoded in the way that it was. And getting that information is crucial to cleaning it correctly. I think it's also helpful to have a sense of how the data set was created. Did it originate from transcribing paper forms? Was it entered into a single system? Is it a bunch of different database tables, possibly from multiple database systems merged together? And that, when you do find errors, can give you a sense of how to clean them or how harmful they are. You know, whether it's likely to be data entry, whether the software has a bug in it that's messing up the dates. And it can sort of guide your decision making. And then finally, I think it's helpful to find other data about the same subject, so you can compare your cleaned data with other values to help identify, you know, whether your aggregate total is in the same ballpark as something else, or whether it's way off, which indicates maybe there is a problem in your cleaning or analysis process. And this is something we did in open elections. We both captured, even though we were most interested in the low-level, precinct-level voting results, we also imported and cleaned the county-level ones so we could compare the sum of all the precinct-level results with the county results. And we actually found a couple of errors in the data the state had published because those numbers didn't equal each other when they should have. Usually the first thing that I do when I'm cleaning data is just to open it up in a spreadsheet program and do a visual inspection and look for things that are obviously wrong. That would be something like a column that's mostly empty but has a few entries in it, a column where most of the information looks similar, and then there's a few values that stand out as being a different type of data, which might indicate that the columns have shifted because of a forming error. And I'll often try to sort the data in a particular column alphabetically. It's a good way of finding sort of mangled values that are outside of the scope of what you expect. I think CSV Kit, it's one of the tools I mentioned earlier. It's a command line sort of tool for processing tabular data. It has a command in it called CSV stat that can give you a quick sense of what the data in a particular column in your file looks like. So I'm running this on my convictions data set and on the statute field. So that's the reference to the law, and it's telling me what the most frequent values are, how many unique values there are, and the total number of rows. And that
they're empty values.
Yeah, that they're empty values. So that can quickly just sort of help me sanity check the nature of that column. Are the most frequent values what I expect them to be? I noticed that there are two very similar values, and that's something I'll probably want to investigate later. And if you're using Refine, the faceting tool in Refine can do the same thing. It got cut off a little bit, but if you click on any column, there's a contextual menu, and you choose facet, and over here it will show you a list of all the different values for a particular column and the number of items in that column. It's a really good way to quickly identify things that might be similar that should be merged together. Even better is using the cluster button. If you click that, you get a dialog such as this. It uses some language processing algorithms to try to automatically identify values that it thinks are the same thing. This is a good way, again, to get a sense of how dirty your data is. And you can, as you can see here, you can ultimately use this to change the values of all the matching records. So I could, if I wanted to do the cleaning at this point, I could put in the canonical statute that I wanted here, and all of these records would be updated to have a matching value. It's a pretty awesome tool. These sliders are also really useful, so if I'm only interested in sort of clusters that have a lot of possible duplicates, duplicates is the wrong word, a lot of values that are different but mean the same thing, I can slide this forward and look at only the high value ones. So we're almost ready to the point where we're going to clean our data. One question, since it's so easy to have like an Ahab-like obsession with getting this pristine data, is what do you really need to clean? You can spend a lot of time getting your data set pristine, but if that doesn't really make it any easier to answer your questions, it's probably not worth your time. One of the things I think about when I'm deciding what to clean in a data set is to think about the fields that change together. So in the convictions table, that would be things like the statute field, which we looked at, the charge description, which is the human readable version of that citation for the law, the charge class, which would be like felony or misdemeanor. Those will all change together. So if one of the fields is dirty, I can maybe use the combination of the other fields to decide what the dirty field should be. Also, as you saw in the Chicago example, our city and state fields were really, really ugly. But the geocoder we decided to use for this data did a good job of geocoding the addresses. If it just had a street address and a zip code, the zip code field in this data set was pretty clean. So I decided to just punt on cleaning the city and state data because I was able to answer my question, how many convictions are there in a given community area in Chicago, just knowing the zip code and the street address. And this is something that David's going to touch on in his talk, so I'm going to get through it really quick. The big takeaway is that there's lots of points in working with data where you'll notice things that are unclean and where you could possibly fix them. In the long run, it's really, really important to make that happen in an explicit part in your process and to document what you're doing. My preferred method of documenting that is actually have scripts that I can run that do all the different cleaning steps. But just like photographers would say, the best camera to have is the one that you have on you. The best way to document your data cleaning is to use the tool that you'll actually write down your steps explicitly. So at the very least, that should be a text file on your computer or even a paper notepad that you have besides your laptop as you're looking at your data in your spreadsheet. But you should write down, what values are changing, in what columns, in what rows. It'll make it a lot easier for other people looking at the data, make it easier for you to revisit the data if you come back to it after a couple of months, and also help people understand what you're doing if there's any problems in the analysis. This is the data, on the screen is the data pipeline that we use with open elections, and you can see that we have a very specific step after we've loaded the raw data where we're making the changes. Some of the refined screencasts talk about isolating and transforming the data, which I think is a really good way to summarize what we want to do. So with each cleaning step, we want to isolate really explicitly define the rows in our data that have the rows and the columns that have dirty values and change them, and sort of do that one chunk of bad data at a time. And just as a quick example of what that looks like in the open elections code base, you don't necessarily have to worry about all the way this is architected in Python. What's important is that we are trying to get rid of duplicate values that were erroneously loaded, because we're only interested in state elections, not city elections. So we isolate the values with these queries to our database, and we delete them. And this has a very specific, this module of code that does that cleaning step has a very specific name that's clear what's happening, and it has a document string that describes what's happening. So somebody looking at the code base can know how we're cleaning our data in this way. And I'm just going to leave it at that, because I think that David has a lot of more details about the data cleaning pipeline, and I want to get to leave time for questions at the end, and also for maybe playing with some of your data.
Aw. Unfortunately, I don't have any cute cat photos in my presentation. Hi, everybody. I'm David. I am an applications developer for NPR. I found out recently that it's just NPR. It's not National Public Radio anymore. Just NPR. I work for NPR. I didn't realize that. Jeff covered a lot of what I'm going to talk about, but we're going to dive in a little bit on a specific use case and a specific process that I went through. The slides are available at recoveredfactory.net/data-workflow. And if you go there, there's a blog post that also describes this whole process in a little bit more depth. There we go. So the case study is a recent article that I worked on with a couple other reporters at NPR. The Department of Defense's Defense Logistics Agency's Law Enforcement Support Office, so the DoD's DLA, LESO, runs a program called 1033, which is named after the legislation that created it. It's been around since the early 90s. It's an artifact essentially of the drug war, but then became sort of justified based on the war on terror. And what this program does is local law enforcement agencies can apply to this program and can get free surplus military gear. And so you guys probably saw the images coming from Ferguson of police officers with, M16 rifles and very big tanks. And a lot of that equipment is going to law enforcement agencies through this program. And when they say law enforcement agency, they also mean departments of fish and wildlife, local school district law enforcement agencies, all kinds of agencies are receiving, big tanks, grenade launchers, bayonets. And so, after Ferguson, this story became a really important story. We'd already been working on a story around it. We had the data a couple weeks before that story blew up. But Ferguson really brought it to national attention and made it an even more poignant story. So the end product was a story that we wrote and published on npr.org. These are some charts that show the time series of what equipment went out over I guess it was an 8-year period from 2006 through the middle of this year. MRAPs and bayonets, what we know about the Pentagon's 1033 program. It was written with Arzu Rizvani, Jessica Pupovac, and Tyler Fisher, a couple other reporters and developers at NPR. So there's one rule for doing all of this. Jeff covered it, I think, really, really well. Automate everything. Make sure that everything is going through a well-understood, repeatable process. always preserve your source data. Never, ever change the original raw data that you're getting. Create scripts or processes to carry out repeatable transformations. Isolate each one of those into single steps. What we did in this case was to import into a relational database so that we could merge our data with other data sets like census data and categorization data. Manage the processing code with version control. So if you're writing code, if you're using OpenRefine, it's a little different process. But if you're actually writing code, use Git. Store it in Git and make sure that you're managing your code that way. And then similarly, to create any kind of analysis or summarization, encode that as well. Never do one-offs. So always put that in your Git repository. Always make sure that you're tracking that as well so that your process is repeatable end to end. So that if an editor asks or a policy flag or public relations flag comes to you and says, how did you come up with this number? You can say, that's how we came up with that number. You can see how the process worked. And I had to do that with this project. The Department of Defense wasn't totally happy with how we categorize certain things. So even if you don't write code, I think our simple control script is pretty obvious. Import the data, summarize the data, and then export the data for a public data dump at the end. Now we're going to get into a little more code. Well, actually, not quite yet. So, like I said, use version control and work in public. So we pretty quickly, in the course of this process, just put up a public repository, even before the story was written, so that the world could see what we were doing. And if you have that luxury, do it. It's really, really helpful. We'll talk about that in a second. So the fields that we had in this data, state, county, quantity, units, acquisition cost, ship date, and a thing called the national supply number. Two things that I just want to point out about this that were interesting. This goes to kind of Jeff's encoded value thing as well. A bunch of news outlets reported a total cost for certain kinds of equipment under this program, and what they forgot to do, and I'm not going to name names, but there were some pretty big fancy news outlets. They forgot to multiply the quantity times the acquisition cost. So they actually lowballed the total value of equipment going up quite a bit in their analysis. So that was really important. The other thing that was important about looking at these fields and really thinking about them and doing some research was that the reporter who actually did the Freedom of Information Act request and got this data was trying to hand categorize all the data, like going through and saying, this name of this item is a gun. This name of this item is a knife. And what we found out is that this national, that's incorrect, it's the national stock number. But in all events, this national stock number has a little 4-digit code at the front of the number, and it implies a category based on a well-known federal categorization system. And so she'd been, she spent an afternoon trying to hand categorize this data and threw her hands up and was like, how are we going to do this? And then we did a Google search and found out that the NSN stands for National Stock Number. The first 4 numbers of that are the federal supply class, and we can use that to say, these are guns through 30 millimeter. These are grenade launchers. These are aircraft. These are vehicles. So doing a little research on the data ahead of time, we should have done a little research on the data ahead of time, but we caught it pretty quickly. And that actually, that number became like a really, really key part of our analysis because it let us categorize this data in this useful way. And again, when the Department of Defense called and said, well, how did you categorize this data? We were able to say, so we went to a Department of Defense website and we downloaded your categorization scheme and we applied it to your data. And so that was really powerful and useful too in this process. So I just want to show a little bit about of the nitty gritty. So we take the Excel data, so we had data from Excel, and we turned it into simple CSV files using the Python programming language. We had to parse the date field, so one of the dirty things about the data that we were looking at is some of the dates were nice and neat and orderly. Some of the dates were these big, long, weird numerical strings, and we didn't know what they meant, and so we had to call the coordinator and find out how, the coordinator of the program, and find out actually how to process those. There were extra spaces in all kinds of fields, just space, 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 and so that made the analysis difficult. So we stripped out the spaces, and then we took that national stock number and split it out so that we could do analysis later. And so this little bit of code just splits this number which has hyphens in it, or this identifier which has hyphens in it, and takes the first value, which is that federal supply class, and assigns it to a new field called federal supply class. You could do this with OpenRefine as well. But fairly simple code to do that. And then we import the data to a relational database, and wind up importing several other data sets as well, so that we can start doing some more advanced analysis. So we generated those CSVs from the source data. We import those. We imported a thing called a FIPS crosswalk file. So every county in the United States has a code called the FIPS code associated with it. And so our source data has county names. The census data has FIPS codes. And so we have a file that lets us merge those two together. We imported a CSV file that has those federal supply codes. Like I said, we got that from the Department of Defense. And then we imported county population estimates from the American Community Survey from the Census Bureau. And so down here, it's just a simple create a table based on this FIPS CSV. And then we had one other piece of data that sort of stood beside our main analysis. We had a list of every agency in the country that received data in this program. Nothing about what they received. We only had that on a county level. But we thought that this might be interesting, and in fact, it became pretty useful for other reporters. And like Jeff said, CSV Kit, which was actually created here at the Chicago Tribune, is a really, really handy tool for handling this kind of data. So what this little bit of code is doing is it's taking a spreadsheet that has 3 separate sheets, worksheets within it, stripping out a couple columns that you don't need and mashing it all together. And that's happening in actually just 4 lines of code. And that's pretty handy. So it's just extracting 3 different files based on those 3 different worksheets. It's using a command called CSV stack, which mashes those files together and adds an additional grouping field to identify where each one of those came from, and then a command called CSV cut, which is taking out a couple columns when we create the data. And so what's cool about that is that in 4 lines of code, it took a little thinking to figure out exactly how to make this work. But in 4 lines of code, we went from a fairly messy multiple worksheet spreadsheet to one single easy to import CSV file. Or you could just even open that up in Excel and analyze it that way. So then we merged the data with lookup tables. I mentioned we have this FIPS crosswalk and this federal supply class. I'll show you in the next couple slides what that actually means. So then we wrote SQL statements and then exported the results of these queries to files so that we could always repeat the process, like I said. And I won't get too bogged down in what this all means. but basically what we're saying is we're going to group by the category that the items are in. And this is the important line. Sum quantity times acquisition cost. So that let us get more accurate, or the accurate numbers for how much the equipment was actually worth. And so that query is very useful. And this one's also really important. Summarizing time series by category. And the reason why I want to show this is the time series can be a really, really handy, just analytical tool. When I worked at the Chicago Tribune, we had all this crime data. Figuring out how to kind of get it into a form that you could use easily was difficult. But what we realized is that you could count per day each type of crime. And so that let us take, millions of rows of data and get it into this form that was much more meaningful and much more useful. And what we were able to kind of determine by doing this query in our reporting is that it would seem, we don't know for sure, but it would seem that a lot of this program isn't driven by law enforcement needs, but by what the military has on hand. So at the beginning of the program, a lot of guns went out because apparently there's a surplus of M16s and military rifles. At the end of the program, presumably as the wars in Iraq and Afghanistan were winding down, a bunch of tanks and trucks went out to the law enforcement agencies. So let us make some hypotheses about what we were actually seeing in the data. And we were able to do that by doing these time series queries and generating data from that. And then finally, at the end of the process, we dumped the data. So I feel like this is really important. So not only did we release our source code, we created something on Google Drive that you can go to and you can download the data yourself. We continued doing Freedom of Information Act requests. So we actually got state-by-state data that said which agencies got what equipment. So we have about 18 of those states. And you'll notice something, a guide to the LESO data, read first. So this is a data dictionary. It explains what we saw. It explains how we process the data. I think that's also really, really important when you're doing this kind of a data dump to document exactly what you did. And then we have the output that we've been talking about. So this whole process was really interesting because I have one byline on npr.org at the moment. So this means I'm batting 1,000. I've already had to write my first correction. But what was great about this is that we published the piece, and alongside it we published the blog post, and we published we publicized the fact that the code was already out there in open source. And a couple hours later, a friend of mine on the West Coast called me up. He's like, "Your methodology with the census is wrong." That wasn't the most fun thing, but it was actually awesome because we were able to catch the issue really quickly, because we were working in public, because we had this process that was open and that was fairly understandable. And so, thanks to census expert Ryan Pitts for catching our mistake. This is why we open source our code. And it actually turned out that it only threw off one number by about 0.25% in our analysis. But it was really, really useful to be able to catch that and immediately be able to issue a correction. And it also makes you wonder, when people aren't sort of going through this process and being fairly transparent about it, how many of these little errors are kind of sneaking into the things that either we're generating for our bosses or that we're reading in the media. So impact, we had some impact. This was really surreal, but Rand Paul cited our story a couple weeks later in testimony on Congress. Mr. Estevez, in the NPR investigation of the 1033 program, they listed 12,000 bayonets have been given out. What purpose, what's the purpose for the bayonets being given out? So that's him. on Capitol Hill, citing our work. That was cool. That was a little surreal. And also impact for our member stations and for other journalists. After we released the data, several NPR member stations took the data and wrote their own stories, did their own follow-up Freedom of Information Act requests. So here in Washington State, they were looking through the data, and so then they did a FOIA request and found out that their Washington State police departments who received some of this equipment and then for a variety of reasons pertaining to the misuse of the equipment were suspended from the program. They're now FOIAing to find out lists of all the equipment that was lost. It turns out it's quite a bit. A couple other news outlets looked through the agency list and found that school districts, like elementary and high school districts, were receiving things like grenade launchers, and so they did reporting on that. So that's all I've got. Hopefully we can move into questions. But this was a really, I have to say, this was a really fun process, and I think really exemplifies kind of like just kind of the nitty-gritty of doing this kind of data processing. So yeah.
Can I ask you a quick question?
Yeah.
When you had to make the corrections, approximately how many lines of code was that? Did you have to change to fix it?
So we had to take out probably about 5 lines of code or 6 lines of code. Basically, the American Community Survey provides 1-year estimates of population for places counties greater than 65,000 people. 3-year estimates for counties greater than, I think, 40,000 people. And 5-year estimates for everything else, or 20,000, sorry. 5-year estimates for everything else. And what we didn't realize is that you can't combine those data sets. You should just use one. And so because we were looking at the whole country, all counties, we had to go back to using just the 5-year data set. So it only threw off one number in our analysis. If people were actually looking at the raw data, it threw off quite a few more numbers. But we were able to really quickly correct it and issue the correction. It was kind of interesting because actually when we tweeted out, hey, we've got a correction, people were really happy about that. And actually that got retweeted more than the original announcement. But we actually got, our audience was really, really happy about that. So that was actually pretty cool.
It sounds like that's sort of a win for the data pipeline or workflow that you described, because you're doing this part of the analysis in a very specific step, a very specific module in your code. You can find where to change it and change it without a lot of pain, and just rerun everything to bake better data.
Yeah, the guy who found it, it was just like, go delete lines 54 through 60 or whatever it was.
So
yeah.
We could just open it up for questions, but maybe before we do that, I wanted to ask a question to all of you. Are there any tools? We talked about a few really specific tools like custom code in Python, CSV Kit, and OpenRefine. Are there any other tools that you all use in your data cleaning work, or like stabs at data cleaning that you think are important to mention?
So we use Pentaho Data Integration. Open source. It allows you to type data in from a whole host of sources and list out in whichever way. It's a visual program, yeah. DI.
Anybody else?
I actually want to ask a question just based on this. I'm a complete noob, and the instant you opened up Python, I was like, oh, okay. So my question for you is, some of the things that you guys did in terms of cleaning your data, is it possible to do with more simple, low-level things like, I don't know, Excel macros?
I've done, I think that in a pinch, doing something in an Excel macro is a fine way to do it, and I've done it before. I think macros are good as opposed to writing some crazy formula that's really hard to read and understand.
Mm-hmm.
It's a great way to do it, one of the takeaways is that you still want to have a pipeline. So you want to maybe keep your dirty column and then make a
Yeah.
copy of it that you operate on to do the cleaning. Hopefully we'll have time to bring up some data in Refine, which might be is a good sort of bridge that might be a more accessible tool.
Yeah. One other thing is like, I used to like mostly use Excel or Google Docs, and then eventually like, as I did more and more things in sort of like the Python documented pipeline process that they sort of use, it becomes a lot easier, and you gotta invest the time, unfortunately. But it pays off with all sorts of like reproducibility and like, for me, like the ability to test it and like say like, is A equal to A in my data, and the documentation for like CSV Kit is amazing.
If I may, one more question then, just on that. Let's say I wanted to basically learn a language that was very good for automating processes. Is Python the go-to language for that?
I'm not going to go as far as making that claim,
Mm-hmm.
but Python does a good job of it, and I think there's a large community in Chicago who are using Python around open data. I would learn the language that people that you can call up or email or meet face to face and help you out are using to do this kind of work. Maybe that ends up being Ruby, maybe it's R, which is less likely, but the language where you can get help is the one to learn.
If you're not
And
gonna
I-
make the claim, I'm gonna make the claim, yes, you should.
Thank you. Thank you.
And I will also just say, so Chris Groskopf recently rewrote the CSV Kit documentation, and so there's a detailed tutorial using this law enforcement support office data.
I haven't seen this.
That is awesome. So if you want to, it doesn't require learning much programming, but if you want a very simple kind of introduction to how to do this stuff on the command line, this actually turns out to be a great tutorial for just learning the command line. It takes probably about 3 hours to go through this whole tutorial, and it's really, really good, really well written. So, another kind of like intermediate, you don't necessarily have to learn the code, would be to read through this tutorial.
And if you want to get involved in Python, Anaconda is a nice distribution that you can download as open source.
I thought you were making a pun. I'm so sorry. Go ahead.
Anaconda is a nice package. Runs on Mac and Windows.
Yeah, it's great for that. I have a Windows machine at work. I need to get Python on it, and I need to get all the tools like CSV Kit. That's actually like a real pain point in Python that I feel like is not done well by the language. So that kind of great. So like, I know nothing starting place.
Awesome. Thank you, gentlemen.
Any other tools? Does anybody have data on like a flash drive or on their laptop that is dirty that they would want to or would be happy to throw up on the screen, and maybe we can look at it and open Refine? Or would anybody like to play with the convictions data set and try to do some of those transforms that I talked about that I did in Python code in Refine, just to see how you can use them with a graphical tool? Or we can eat lunch.
What kind of data would you want to see? Like, I don't know why I'm asking a really beginner question, but like, my immediate response was like, we've collected like 150 results from a survey. But like, is that, I mean, you're probably talking about like hundreds of thousands of pieces of data, am I right?
No. I think, the data I'm interested in is the data that people need to use to answer their questions. And if you have 150 survey results, but because you just got volunteers to key in the data, and you have a lot of fields that are like yes, some that are Y, some that are YSE, and that makes it hard for you to answer the questions that you have or to give the numbers to your funders, like that's a data cleaning problem that we should talk about. So.
Okay, then maybe, yeah, let's do it.
Yeah, let's do it.
Bring it up.
Okay, how do I?
Do you have a flash drive, or if it's in
I
Google?
can share it on Google. Is a Google form that gave us a spreadsheet.
Cool. I'm trying to think of the best way to share it. Maybe if you can just download it on a flash drive, that might be safer. I just don't want to like mess up the permissions on the spreadsheet, unless it's something.
Make a copy and share
Email it to you.
Oh yeah.
Make a copy of that.
Let me write down my email.
Use email is also a tool, by the way.
Just email Jeff.
I can make a copy of it and email it.
Yeah, if you could do that, that would be awesome. And while you're doing that, I will try to get up on screen.
Do you have a feature import?
Can you read that? It's at the bottom of the tools note.
Gentlemen, if you don't mind all the questions. One
Yeah.
other thing that was kind of cool was what presentation program was that? I think I saw Tarbell.
So it's a thing called Reveal.js.
Reveal.js. Another program or two, I'm imagining.
It's actually it's a JavaScript library, but you just write HTML.
Huh.
So if you know HTML, you can write slides.
Cool.
I used the thing called Tarbell, which is a static site generator we made at the Tribune with it, but Jeff just wrote HTML.
Cool.
Yeah. And I also set up, if you can't get on their Wi-Fi, there's a network called Paseo.
Oh, cool.
And it's the password is division string.
Oh,
it's just all lowercase, all one word. And
Cool.
it's running off this.
Nice.
Well, Jeff's doing this. Does anybody else have questions? Comments?
Your clean data became a report after you did all the cleanup.
So we wrote a story and then published it also to a Google Drive so that people could access it that way too.
Became a public record.
Yeah.
Could you show us where your report was, your story?
Yeah.
Completed your report of what you have done?
Yeah, so it's linked to in my presentation, which you can get. I can write down the URL, but it's recoveredfactory.net/data-workflows.
Okay,
You just
I'm
put
gonna
it
write
up
it
there.
down just for
What's
the
that?
sake of,
Oh yeah.
Okay, let me.
Yeah, so the link, if you go to this URL, you'll get these slides, and the link's in there. I don't know. It's a
I'm
big,
just
long, scary.
Curious to see how after you all done that work you did, what it looks like.
It's mostly just paragraphs.
Okay. Recover Factory.
Sorry, I'll switch it back.
.net/data-workflow.
Cool.
So do you want to first tell us what YSK does?
Okay.
Before we
Yeah.
I know. So, I work for Youth Service Project, and we ran, I'm the Career Workforce Development Specialist. So we don't really have a across-the-board communications plan for how we communicate with our youth on a year-round basis. So it's usually like one-off. I let somebody know about a program. So I created a survey along with some of our youth to try and gather information about how they want to be communicated to, so that we can figure out the best way to do that. And then I have Denzel and Kyra here, who were a part of my program this summer and kind of helped. We were what I call the Dream Lab team, and helping to further get information from other youth to like populate this survey and get an idea for like how we should communicate with our youth, like where are they at, what information do they want, and how best to communicate with them.
And before we swing the camera back, do we need to be careful about exposing names on a live stream? Personally identifying information? Because I saw there's email addresses and phone numbers in there.
I mean, is there? There's.
I just want to make sure we're not.
Permission based, but I don't know if it was like permission to have their names.
Can you hide the columns?
Probably not.
Yeah.
Maybe what would be cool is if we did that as part of our data cleaning.
Yeah.
Maybe we can just like turn the camera off and then we'll clean that real quick and then we can turn it back on.
Or here.
All right, I'm gonna.
I can stand over here.
You're the distractor.
So Refine, it's a free tool. If you Google for Open Refine, you can download it. I know it runs well on Macs and on Linux, and I think it runs on Windows as well, but someone else could. And it runs in your browser, so you run a command, and then let's see, it opens up a browser window, and I'm just creating the project from the CSV file. Cool. All right, so what I'm going to do, I'm just going to remove this column. And this seems like pretty destructive, but the nice thing about this tool is that it has a really awesome undo history that gives you really explicitly what steps you're taking, and you can just undo a subset of that. So your original data is still in the system somewhere, even if it's not showing up on screen. So we want to get rid of, we'll just get rid of the name for now.
Weird question. Can you undo changes that you've done out of order?
I believe that you can.
That's cool.
And another thing that's cool, right, that I just found out is that you can export a set of changes and then replay them on another project. So if you have maybe the date column is formatted the same, and you have a little step that you use to get the date and the time as separate columns, it's pretty awesome. So
And it's really good if you have data that updates, so you can run it every month as you get new stuff in, and you do the exact same process on it.
all right. I think this is, does anybody see anything?
Can I ask a really basic question?
Sure.
Just so I understand something you said today. How did you even get the data into Google Refine?
Okay, so let me, so what we did, the first thing is, it started out as a Google spreadsheet, and I'll just step through that really quick. So here's the spreadsheet in Google Sheets. I went to File and Download As.
Oh, okay.
And I chose comma separated values.
CBI.
That saved it on my hard drive.
Okay.
And then when I went to the home page for Google Refine, this is what pops up when you run the Refine command. It brings up a browser window, and you see this create a project dialog.
Wait, you just do a Google search for Google Refine or go to whatever the website is for
So
Google Refine?
this is a part that's a little bit confusing. Google Refine uses your web browser as the interface to it, but it's software that runs on your program. So you just you'll have to download the software, unpack it, unzip it, and then run a command.
Is
But
it available for Windows?
I believe that I think it's written in Java, so I think that it should run in Windows.
Yeah,
Yeah,
I've
it
run it
does.
out.
Cool. And so to import that project, I just look for the file on my hard drive. I click Next, and just answer a couple questions about the nature of the data. And after that, it gets back to the project that we were looking at. So it's just like you would upload a file to a website. It's a similar dialogue. The only difference is it's a website that's running on your own computer. So let's look at one of sort of the obvious thing that I would do here is do some quick, use Refine to do some quick analysis of this data. So this looks like this field is what is your current status? I want to know in my of my respondents really quickly, are most of them high school juniors? Are most of them college students? So I'm going to do a facet. I get to that by clicking on this down arrow here. I'm going to do a text facet. And I see all the different values.
Frequencies?
And the little gray number is frequency. So I can sort that by frequency and see that most of the respondents in the subset of data were high school seniors, followed by college students. And I'm looking, and this gives me a good idea of all the values. So are these distinct categories, or are maybe some of them things that should be grouped together? And
So,
Mhm.
I think it's what kind of info would you like? If people could select multiple things for
Mhm.
that. What would you do with that? I always
Yeah.
struggle with.
Yeah. So this is a good. Let's look at that. What kind of info would you like? So to me, in a lot of cases, it looks like this is separated by commas. And I'm a little rusty with my refined syntax, so I might not be able to get this working at the moment, or I might have to Google for it. But what you'll do is you'll choose you'll go down to edit column and choose add column based on this column. And let's see if this actually works. Maybe I don't have this installed. Okay, so I'll look up how to do this, but let me explain what I'm going for here. And that is, what I'm going to do is I'm going to create a column based on the existing column. And I want the value of the new column to be, I want to take this string, and it looks like each value I'm interested in is separated by a comma. I'm going to use a tiny bit of code. So this is a nice thing about using Refine. You do have to learn some code, but the amount of code that you're writing and learning is pretty minimal. I'm going to split this value based on the comma and choose the first one. Now the one thing that makes this harder, that would be easier in a database program, is that there's going to be a variable number of potential columns. So to capture each of these, we'd have to repeat this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. But that's not the worst thing in the world. But that's how you would address it. You would use this program to create new columns based on this first one. And the nice thing is that, again, it's not a destructive step. It's keeps that original value and also breaks it out. So let me. I'll try to actually make that happen in a second. But are there any other sort of insights that you're interested in looking at? Just from what we see up here, maybe another interesting facet would be, how would you like to be contacted? Oh, so this is really interesting, and unfortunately, but this is a good example. So it looks like we were able to identify a place where the data isn't clean, that we'll want to, just from looking at the facet and seeing one of these kids is not like the other. But what you can do is, what's neat, I'm going to hide that so this person's data isn't out there. The other feature of this facet box is that you can click on one of those items and it will automatically filter what you see over on the right hand side to those results. and that's sort of the identify part of that two-step process. It makes it really easy, say, if we wanted to just flag or star them, just to be able to find them quickly in our data set if we go back later, or if we say we want to make a clean data set that we're going to export that has no high school juniors in it, we could select all of these and choose to remove all these rows. Is there anything else that we want to look at before I really quickly look up how to split that column into multiple values?
Is that open? Is that an open text field? The what is it? The column. What do you currently? Oh, what do you currently?
Oh yeah, so this was a question that I couldn't figure out how to get a good set of information from. What do you currently use to get information about jobs or programs or career advice? And I put be very specific because the first time I tried to do this survey, I gave examples of like, for example, website, your family, your friends, and then they just wrote website, family, friends, and I was like, no, I want to know exactly, like, do you go to Snagajob, or do you go to Monster, or do you go to, like, you know, do you have a particular counselor, or, you know, so I wanted to have more particular information, but I didn't want to give the answers because that would remove the opportunity for them to give more diverse information.
So let's try something. I'm not going to guarantee that this is going to work, but it might, and that would be really cool. So we'll create a facet again on this column. I'm going to close out the original one, and I'm going to choose cluster. And so this identifies sort of common themes. So looking at those values, there were multiple people who said some versions of people or websites or a combination of the two. Let's try a different. And there you have a different cluster. I think because of the length of the fields, this doesn't work that great. This is an example of where you might have to get into a heavier, sort of like a heavier tool set than.
Or just hand categorize it.
Yeah, or hand categorize it. But this is another example of where using this tool could be helpful in hand categorizing, because then you could hide all the other fields and export a spreadsheet of just these values. And so somebody who's categorizing it is just looking at those values and filling in another column in the spreadsheet and doesn't have the opportunity to possibly mangle your other data. And what makes that neat is that it Refine it assigns each record an ID, which is something that's not apparent in the Google spreadsheet. Internally, it has that sense of an ID, but in your data, it doesn't. And that is really good to do. If you're not using a tool that does that, you should if you're just using a spreadsheet, you should give all your records a unique ID. So if you are doing some external or crowdsourced cleaning component, you can then have a way of merging those changes back in. So that might be the easiest way to address it, is just to use a tool like this to extract just the values that you want to hand code along with the IDs, and just have someone look at them and fill them out. Any other questions about this particular case? All right, I'm going to try to split that column up.
Just the one Jeff,
What's that?
Said that we should break right at 12:15 because lunch is ready.
Okay.
What OpenRefine does, is that how you get the results? Like, you know how you can see responses from Google Sheets and it gives you kind of like this visual data, like quick visual data set information based on the responses of your, is that partly like how it's doing that? Using like this similar kind of functionality? Does he ask?
Yeah, I think it's probably using similar algorithms, but it's separate systems. And the distinction is that's a good way to get like some quick insight, and this would be a better way for both getting that insight, but knowing that you're going to want to clean some of the data as well.
Yeah, because even looking at those results, you see that it's not going to give you the most accurate information that you want to get out of
Yeah.
it. 'Cause
Something I would probably do with this, for instance, is like to split out the date from the time, so I could sort of more easily group do the sorting of the or grouping of the data by date, if that's something that you need to do. So let me try to just do that really quick.
Jeff, make sure you don't want split into several columns.
Split.
Yeah, there's that option.
Oh, cool. Do you think that's what I want? Oh, see, this is
So that's
great.
great.
So by separator,
Further seals.
Beautiful.
and yeah, so it has it
Yeah.
names them with a number, but now we have that field that's in a single column split into multiple columns. So that's awesome that they sort of identified this use case and built it into the software. Something I didn't know about.
Well, but the difficulty with that data is that it's only numbering
Yeah.
the amount of data points. It's not separating them out by category, right? So if I chose 5 different things that I want to know, and you only chose 3, it's only going to choose like the first column is only going to be like what I chose as number 1.
That's right.
You know, which would be good if you say, what are the top 5 things I want to know about, and then so then you see what everyone's priority is, like as a ranking set of data, not like how like if 50 people said I really want internship information, but only 10 of them said that's the number 1 thing that I want, you know, that's a different statistic than.
Yeah, because it is like job fairs are there, but then they're also down
There's
there.
also-
and
yeah.
Yeah, what you'd really want is like job fairs.
How many
All
people
in
said
one
job fairs?
place.
Yeah.
Yeah.
So I think what I would do is like maybe use that. I would use this to split the field and then bring it into some other software to reshape it in a way that you could query it. So again, this is like even for this simple data set, it ends up being a multi-step process. Maybe we can talk a little bit offline about a good way of doing that. But yeah, I see what you're saying. But it's good to, this can at least help you clean up your data a little bit to make it easier to import it back into a spreadsheet program or into a database to do that sort of next step analysis.
I mean, it's also good to look at this and how it works so that when you create a new survey or think about how you're asking these questions that you're asking them, knowing what kind of data set you want to end up with.
Yeah,
Yep.
so maybe you would
Or how to
ask them
present that.
top, what is your first, what is your second, what is
Yeah.
your third, and let them only pick one, and that makes your data a lot easier to work with.
Yeah.
So this is, sort of doing this with a very small set of data like early on, or testing your survey, I think can save you a lot of time and headaches when you get to the analysis process like months later. So it's lunchtime,
Great.
but I'll be around for lunch and a little bit after if you have any questions, or you can hit me up at my email address or on Twitter. I like talking about this stuff, so I'm happy to take a look at your data and let you know what I think about it.
Thank you very much, guys. All right, time to eat. That's great.
Oh, yeah.
Yeah, I wonder if that's what the multiple columns can do that mapping.